You know, when you look up at the night sky, you probably see stars, right? Well, what if I told you there's also a massive, growing junkyard up there, and it's seriously threatening our future in space?
So, what if we could turn all that junk into rocket fuel? I know, it sounds like something straight out of a sci-fi movie. But turning our own space trash into fuel to clean up our cosmic backyard? That's the brilliant and very real idea we're going to dive into today.
Okay, but before we jump into that incredible solution, we really need to get a handle on just how big this problem is. I mean, we're talking about a cosmic minefield orbiting our planet right now, and yet, we're the ones who made it.
So, what exactly is this space junk? Well, forget about just dust. We're talking about whole, defunct satellites. We're talking about leftover booster rockets from launches. And then you've got all these little pieces of discarded hardware, fairings, even stray bolts, and entire solar panels. It's basically everything we've left behind after 60+ years of exploring space.
And look, this is way more than just a tidiness problem. You've got to understand every single piece of that debris is basically a bullet traveling at thousands of miles per hour. Imagine one of those hitting a satellite that gives us our GPS or our weather forecasts or our global communications. The result, it would be absolutely catastrophic. But the danger isn't even just from one single impact. The real fear, the thing that keeps people up at night, is something way bigger. It's the risk of a chain reaction, one that could just spiral completely out of control.
And this terrifying scenario actually has a name. It's called the Kessler syndrome. It was a theory proposed by a NASA scientist, Donald Kessler, way back in 1978. And he warned that we could reach this tipping point, right? A point where there's so much junk up there that the problem just starts to feed on itself. Okay, so let's break down how this domino effect would actually work. First, you get one collision, just one, but that one impact shatters those two objects into thousands of new, smaller pieces of debris. Now all of a sudden, you have thousands of new little projectiles flying around up there. And what does that do? Well, it skyrockets the probability of even more collisions, which, you guessed it, creates even more debris. This chain reaction could just keep going and going until low Earth orbit, that critical area where most of our satellites are, becomes totally unusable. It would literally become a no-go zone, effectively trapping us here on Earth.
So yeah, it's a pretty daunting problem. But you know what? It's also a perfect chance for human ingenuity to really shine. So now, let's get to the good part. Let's look at this incredible solution that just flips the whole problem completely on its head. So the first logical idea, right, was to build some kind of cosmic tow truck. They called it a space tug. The plan was for this vehicle to fly up, grab a big piece of junk, and just pull it down so it burns up in the atmosphere. Sounds simple enough, doesn't it? Well, not quite.
And here's the kicker. Every single little maneuver you make in space costs fuel. A space tug like that would need a ton of it. And refueling it? That would mean launching more and more expensive rockets from Earth, again and again. The cost just becomes, well, astronomical. It makes the whole idea pretty much impossible.
And this is where the breakthrough comes in. This is the genius part. What if the tug didn't need to be refueled from Earth at all? What if it could just live off the land, so to speak? The new idea is to have the space tug literally eat the junk it collects and turn it into its own propellant. I mean, this changes everything. The mission goes from being totally limited by its fuel tank to one that could operate continuously, maybe for years, and that just slashes the cost.
Okay, so you're probably wondering, how on earth is that even possible? How do you turn a random chunk of metal into rocket fuel? Well, it all comes down to some seriously clever physics.
All right, let's walk through the process step by step. First, the tug captures some of those smaller pieces of debris and funnels them into its engine. Step 2, it uses really powerful microwaves or induction coils to heat that material up, intensely. Step 3, the debris gets so superheated that it actually turns into an ionized gas, which you might know as plasma. And finally, step 4, that plasma gets blasted out the back of the engine and boom, you've got thrust. It's what pushes the tug forward.
And get this, the whole system is electric. It's powered by huge solar panels. So as long as the sun is shining and there's junk to scoop up, this tug can just keep on moving, hunting for its next target. It's this incredibly elegant, totally self-sustaining loop. So you can see this technology is so much more than just a cool idea on paper. It's a genuine game changer in our ability to actually tackle this massive environmental problem right above our heads. But what would it really take to clean things up? And that's the big question, isn't it?
I mean, we have hundreds of thousands, maybe even millions of pieces of debris up there. So how many of these self-fueling tugs would we actually need? And how many years would it take for them to make a real, noticeable difference?
Well, the honest answer is we don't know the exact numbers yet. They're still being worked out. But you know what? That almost misses the point. The real takeaway here, the big news, is that this technology takes the whole cleanup idea from what was basically a logistical nightmare and turns it into something we can actually do, a tangible possibility.
And that leaves us with a really fascinating, almost poetic, final thought. We're the ones who created this orbital junkyard, right? This mess that's threatening to trap us on our own planet. But maybe, just maybe, the key to cleaning it all up and securing our future out there among the stars is buried in our own trash. Kind of wild to think about, isn't it?